Ecosystems and habitat. The state of the world's ecosystems has changed more rapidly in the last 50 years than at any time in human history. Ocean fisheries are collapsing, forests and wetlands are disappearing, deserts are advancing. A process known as the sixth mass extinction is underway, with species going extinct at a rate not seen in 65 million years. Biologists estimate that if current trends continue, about 50% of all known species will be gone by 2050. Some scientists believe that human influence has initiated a new geologic epoch, which is being called the Anthropocene epoch, a term first proposed in 2000 and now used informally by many scientists. The official body which establishes the geologic timescale is the International Commission on Stratigraphy, and this commission has formed the Anthropocene Working Group to investigate whether a new geologic epoch should be officially designated, and if so, what physical evidence should be used as its marker. Stay tuned. Conservation has changed. Conserving wildlife reserves and restoring wild habitats is important work, but by themselves, those are not enough. These pockets are too small, too few, too isolated. In the modern era of growing population, habitat destruction, and changing climate, we will need to find ways to integrate the human and non-human world, to fuse the bits and pieces together into a larger, coherent living whole in what some ecologists are calling reconciliation ecology. Humans are part of nature, and in a new version of resilient adaptive systems, nature and humans are now co-evolving. Climate. Many scientists believe that climate change is the most serious crisis facing our planet. A changing climate is nothing new. A look at ancient climate shows that Earth has been warmer in the past than it is now. What is unprecedented, however, is the speed of the change. Never in the history of the planet has the temperature increased so rapidly, a change brought about by the combination of exploding population numbers, economic growth, and an industry built on fossil fuels. We have what is known as climate commitment. Even if we stop burning fossil fuels tomorrow, we are now committed to a warmer climate because of the carbon dioxide already in the atmosphere. Even if our most ambitious efforts to lower emissions are successful, the fact remains that we now inhabit a planet that's different than the one on which human civilization developed and on which it has lived throughout its history. It is warm and getting warmer. The question now will be how much and how we and our fellow living beings will adapt. After 2 centuries of fossil fuel consumption, science tells us that the Earth system has become destabilized. Gaia's condition is guarded. Still, there are grounds for hope. If we are very committed, the climate will eventually stabilize and carbon dioxide concentration will eventually begin to fall to a safer level. At that point, assuming that geochemical cycles, remaining ecosystems, and other planetary components have stabilized, the parts of the Earth system which survive will be able, slowly, to soak up the excess carbon dioxide and restore balance. However, much will have changed. Earth, when it settles into a new state of equilibrium, will not be the same as it was before. Between now and then lies the transition, and that is where we live now. This transition back to stability will take centuries. Science tells us that the climate impacts of fossil fuels are expected to last hundreds, probably thousands of years. The work we do now is for a future we will never see. This work, the stabilization of Earth's climate to maintain livability of the biosphere for us and so many fellow creatures, may be the most consequential work any of us will ever do. The human sphere. When we talk about challenges facing Earth systems, people often ask, isn't population really the only problem? It is true that damaged ecosystems, resource depletion, pollution, and water shortages have increased exponentially, driven by human population numbers. But the primary driver of the sustainability crisis now gripping the planet is economic growth. We live on a rapidly changing planet that is fundamentally different than it was when any of us were children. In the last 50 years, population has doubled, consumption of water has tripled, and the use of fossil fuel has quadrupled. Synthetic pesticides and heavy metals are found in the tissues of every animal on Earth. The end of cheap fossil fuels is looming. The sixth mass extinction is underway, with 50% of current species predicted to be gone by 2050. 90% of large fish have disappeared from the oceans, victims of overfishing. Coral reefs are dying. Mollusk populations are shrinking as ocean water becomes increasingly acidic. Mountain glaciers are melting, deserts are growing, sea level is rising, and waves of climate refugees are likely in the near future. The driver of all this change is economic, in particular, the economic growth model that has been at the core of commercial activity since World War II. Continuing the growth model is not just a bad idea, it is physically impossible. The current system releases wastes into the environment faster than natural systems can process them. It consumes renewable resources faster than they can be replenished. It consumes non-renewable resources. Once those are gone, they cannot be replenished. We have the planetary equivalent of a savings account, but it's made of plants, animals, soil, water, and air, and it's known as natural capital. Living systems are finite, and being sustainable means not using them up beyond their capacity to regenerate. This is analogous to living off the interest in a savings account and not spending the capital. The field of economics known as ecological economics recognizes that nature has fundamental thresholds and that growth cannot go on forever. The goal is a steady state economy in dynamic equilibrium, an economy that keeps natural capital intact, living off nature's income rather than consuming its capital. Products. Matter on planet Earth is distributed within 4 major systems: the atmosphere, biosphere, hydrosphere, and lithosphere. Since the Industrial Revolution, the lithosphere has been the source for 70% of the materials used by humans. Once material is taken out of the lithosphere, it cannot be put back. In the conventional approach to products, materials follow a one-way trip from production to disposal. We can try to be less wasteful and produce less pollution, but being less bad is still bad. Resources are still depleted, toxins still accumulated. They just do it quietly and gradually. Cradle to cradle is an alternative approach based on nature's model, where waste at one level becomes a nutrient at another level. It uses 2 separate metabolisms where nutrients recycle continually, biological in one and technical nutrients in the other. Biological nutrients are materials designed to return to the biosphere. Wood and compostable fabric are biological nutrients. Technical nutrients are materials which do not biodegrade. They stay within closed-loop technical cycles circulating within industry. The clothing company Patagonia processes used fibers to make more clothing. The carpet company Interface processes used fibers to make more carpet. Those fibers are technical nutrients. The biosphere is our model for cycling of resources, a closed-loop system where matter circulates and waste from one organism is food for another. On a larger scale, a method called industrial ecology sets up closed-loop cycles among industries, where output from one industry is input for another. And the archetypal example is Kalundborg, Denmark. Waste heat from the power plant is sent to the city's heating system and to a fish farm. Fly ash from the plant is used in a cement factory. Steam from the power plant goes to a refinery and to the biochemical company Novo Nordisk. Sludge from the plant is used to make sheetrock at the gyprock plant. The refinery sends its cooling water and flared gas to the power plant and the sheetrock plant. Sludge from Novo Nordisk and sludge from the fish farm becomes fertilizer on farm fields. Kalundborg's system is a closed loop. Waste and recycling. The laws of ecology tell us that everything must go somewhere. There is no waste in nature. There is no away, as in throw it away. Landfills are just temporary holding areas. Recycling is an improvement over landfilling, but recycled materials still consume more of everything than reusing a product or not producing it in the first place. Most of us focus on reducing garbage, which is technically known as municipal solid waste. But it turns out that our garbage constitutes only 2.5% of the total volume. The majority of waste generated is industrial waste, the byproducts of large-scale commercial activities like manufacturing, extraction, and power generation. We may be asking the wrong questions. Maybe the question should be not, how can we recycle more? Maybe the right question is, how can we stop producing so much waste in the first place? Natural systems are closed-loop cycles. Waste from one system is food for another, and everything gets reused. This is the concept behind cradle-to-cradle design, and it's the concept behind a shift in thinking known as zero waste, currently being implemented in several U.S. cities, including Seattle. Instead of a linear process, take, make, waste, the system becomes a circular cycle. Borrow, use, return. In a zero waste system, every material is a nutrient. Toxins are never produced, and so-called waste does not build up as a legacy for future generations. Every material either returns to the biosphere or recycles indefinitely as a technical nutrient. It's a closed loop with the biosphere as our instruction manual. And I'm going to pause for a couple of seconds for our camera.